So, another non-trivial equation. Let's sketch the graph of that equation. Notice how the domain of this function is all real numbers between -1 and +1 inclusively. I built a sine graph. I took the time to differentiate, plotted the zeros of my numerator and denominator, and built a sine graph of the first derivative function. This again tells me where the original function changes from decreasing to increasing, and then vice versa. Now, in differentiating a second time, I have my second derivative function, plotted the zeros of my numerator and denominator, built a sine graph, but this sine graph tells me when I'm concave up and when I'm concave down. So in getting rid of my scratch paper, putting this all together, now I do have 3 x-intercepts. I live below the x-axis and above the x-axis on the left and right-hand side of the vertical y-axis, respectively. But it looks to me like, even though I'm negative in the left-hand plane, I change from decreasing to increasing about an x value. That's -1/√2. I'll leave the y value for you. Pass through the origin, but then I'm entirely above the x-axis in the right-hand plane, but change from concave up to concave down. I had the same x value, but this time it's just positive, leaving the y value for you. It looks to me like I changed from being concave up to concave down about the origin. That's certainly the case in my picture. So this x-intercept is also the inflection point. I've clearly sketched a graph of such a non-polynomial, non-rational function. That's something new for us.